I'm Diane Griffin, the Vice President of the National Academy of Sciences, and it's my pleasure this morning to welcome you to our book talk. Every year, the Academy's Communications Committee gives awards for science communication. One of them is to an author of a book, and a book that has been particularly helpful, useful, and engaging. In this case, it's a very engaging and enlightening book on the forest unseen that was written by our speaker for this morning, Professor David George Haskell. He trained in Oxford and for his undergraduate, and then at Cornell for his doctorate. And he's been on the faculty of the University of South and Sewanee, Tennessee for 18 years. And as a part of a small liberal arts college, and which owns quite a bit of land around the university that he's taken advantage of in order to be able to study it, as you'll hear, through the seasons. And so I want to welcome Professor Haskell, and we look forward to your talk.
Good morning. Thank you for that very kind introduction. It's a great honor to be here with you, and particularly a great honor to have received the award from the National Academies at a time when science communication, of course, is so important to our society, and also when there are so many great examples of wonderful science books being published now. And so I was humbled by the award, and deeply grateful to the Academies for that recognition. And I'd like to thank the National Academy of Sciences for bringing me here today to share a little bit of my work with you this morning, especially to Diane Griffin, who for the kind introduction, to Sue Wessler, who both of whom extended the introduction to me to come to speak to you when we met last year, and also to Judy Harrington, Jenny Munn, and Sally Schwetman, who helped with the logistics of getting me to Washington and with arranging all my movements and so forth. So it's a great honor and a delight to be with you here on this beautiful morning, and thank you for coming into the inside here when the outside is so tempting. The mall is looking beautiful, and the first migrant birds are coming up from Central America and South America, and the elms are already dropping their seeds out into the mall. So it's a real ecological wonderland that we have right here out to the front door. So I'd encourage you to go out and breathe some of that during the day, in addition to the many wonderful programs that are scheduled for the rest of the day. So let me tell you about my year-long watch at 1 square meter of forest on a mountain slope in Tennessee. My book, The Forest Unseen, describes and reflects on this watch. And today I'll talk briefly about the book, offer a few short readings to give you a taste of what the book is trying to do, and offer it as an exemplar, an experiment, if you like, on how to integrate ecological observation, scientific communication with contemplative practice. Because what I did was sit down and contemplate this 1 square meter in a way that I had not done in all my other previous scientific work or indeed in my teaching. So what did I do? In late December, I wandered through the wintry woods and stopped when I found a rock that looked like it was suitably flat, that could take my rear end with a reasonable degree of comfort for a year. And the area in front of that flat sandstone slab, 1 square meter, became an area that I returned to hundreds of times through that year to sit, to shut up for a change, to try and open my senses to what was happening in this one small place. So to use it as a little lens to hold to the world, or a stethoscope to hold to the skin of this forest. So let me show you some slides to give you some visual context here. Here is the bluff of the Cumberland Plateau where I live and where the book is set. Here we have a sandstone escarpment that drops off into limestone coves. If you move further out here, we're looking southwest, and so Huntsville and Nashville and so forth are out further in the haze there. This is an area that humans have been in for at least 9,000 years. Most of the American Indian presence on the Cumberland Plateau, as far as we can tell, was through hunting, particularly deer and turkeys, and gathering, particularly hickory nuts. And then their larger towns and villages were off of this rocky, mountainous area in the slopes around, down by the rivers where there were abundant shellfish and fish and so forth. So big settlements of people there for thousands of years. And of course, as the old world people showed up from Europe, from Africa, followed essentially the same pattern, is that most of the towns and the agricultural development are off of this plateau. The rocky, particularly on the top of the plateau here, the soils are very, very old, sandstone-derived, very acidic, not very good for agriculture, which is why there are still trees there. The forest is very diverse, as you'd expect for the southern Appalachians. This is a picture taken in the fall, and you can see that each tree here has a slightly different texture, a slightly different color and shape, and that indicates the richness of at least of the large plants in this area. The same is true in the understory. The area that I watched was, as far as we can tell, a small patch of old-growth forest, very rich understory community of plants, and lots of snails and salamanders and other things that the eastern woodlands are so famous for. So I was not up in the canopy. I was down here at the soil level, sitting and watching. The guiding metaphor for the book is the Tibetan sand mandala. This is also about 1 square meter. It's created by Tibetan monks who, over many days, and I'm sure many of you here have seen this because these mandalas have been created in sacred spaces and art galleries and libraries around North America now over many years. These sand mandalas are created by drizzling very fine streams of colored sand over many days to create this enormously intricate sand painting. But the object is not to create a painting. The object is an act of meditation. It's an act of memory, because most of these patterns are created from memory. And ultimately, it's a representation, at least in some of these mandalas, of the path to enlightenment, of the whole cosmos as understood through that particular tradition. So the whole universe is seen through this small circle of sand. The Tibetan insight, of course, is a contemplative insight that as we narrow our gaze, perhaps we will see more and further. We find this in the Western tradition, of course, Blake seeing the world in a grain of sand. So not just a whole collection of sand particles, but one grain of sand, and a heaven in a wild flower. And of course, Christian and Islamic and Jewish contemplatives over millennia now have reported similar findings in their own explanations, in their own explorations of the world. As they narrow their gaze, can they see more and further? And these mandalas appear all over. I encourage you, as you're standing in the great hall here, to look up. And there you will see a mandala created in 1924 by Hildreth Miriere. I hope I'm pronouncing her last name correctly. With ages and cycles of nature in ceaseless sequence moving inscribed, and it was a representation of the totality of science as understood by the various scientific societies and scientists at that time. These days, we would add more to that mandala, right? The science of genomics and many areas of science have pushed beyond, of course, where we were in 1924. But there is a mandala awaiting you as you step out from this building here. So, trying to see the universal through the particularities of something very small. Here's a close-up of just one portion of a mandala. And when these are created, they are then swept up, and their jumbled sands are then cast into running water. So ultimately, the mandala is also a representation of the impermanence of things, which again is an important insight from the Buddhist tradition, but I also think it's an important insight that resonates within geology, within our understanding of cosmology now and of biology. That things as they are now are not as they were 50 years ago or 500 million years ago. So this notion of impermanence, although in the Buddhist tradition it is understood and communicated in different ways, is represented and embodied in this mandala. So in some ways, this photograph is a violation of that impermanence, or at least it seems to be so, right? So these sands have been swept away. But the hard drive and the little flash drive that this image and flicker that this image came from, all that, too, will pass away. We know that for sure. And so in some ways, this picture is just a slight extension of the life of this mandala, and it too will move on. Here's another sand mandala. This is from a rock located on the mountain slope where I sat. This is just a few square inches, and you can see there's probably a dozen lichens and some mosses down in the left-hand corner there, probably tardigrades and all sorts of creatures living within those mosses. So in just a few square inches of sandstone, we have an incredible amount of history. So these mosses capture the history of the fungi and the algae and the bacteria, and the mosses tell the story of at least part of the story of the land plants. So in just a few square inches, we have thousands of stories all embedded, all jostling for position. So the 1 square meter served as a device to focus my attention, a way of structuring the narrative of the book, because after I sat in the woods, I'd scurry off to the library to read up about what people had learned about the creatures, the plants, the fungi that I had encountered there. As a biology teacher, often I knew some of what was happening, but I wanted to say, well, what have people published on this particular creature in the last 5 years and the last 10 years? Where are some really interesting stories here that I could wrap up into some essays and offer to the general public, to non-specialists, to celebrate the lives of these creatures, but also the science that helps us see those lives with more precision, with more, and reveal their intricacies with greater glory, greater depth is the word I'm looking for. So the forest mandala serves as a lens through which to see the whole world, and this, of course, is the paradox of contemplative practice. As we focus in, perhaps we see more. A physical analogy is a pinhole camera. Make a little pinprick in a piece of card or in a sheet, and then the light coming through that tiny little aperture forms a nice crisp image on the wall behind. But it only works if it's a pinhole. If you make the hole bigger, you lose the focus, and if you make the hole much, much larger, like a window opening, you don't get an image at all. So if you're looking for a physical analogy, the pinhole camera is what I applied. Now, of course, I went to the woods not seeking, this is not a book about Tibetan Buddhism or necessarily about religious contemplative practice. I was seeking to apply the insights of the contemplative approach in the context of ecological observations and of scientific communication, of scientific storytelling here. So it was the wonders of this world rather than some other world that I was seeking in my returning again and again to this 1 square meter. So my motivations for this project were twofold. One, I wanted to go to the forest without an agenda for a change. As a scientist and a teacher, I go into the woods a lot. And as a teacher, there's a lesson plan. Today we're going to talk about natural selection or the carbon cycle. As a scientist, I'm going to collect DNA from these creatures, or I'm going to measure distribution and abundance of a particular group of organisms. Again, I'm coming with a preconceived notion of what I am going to see, what I'm going to be querying nature about. And those are fabulous practices. It's great as a scientist, I don't need to tell this group, to have a hypothesis, at least a little vague notion of a hypothesis or a question as you move forward. As a teacher, having a lesson plan, at least a hazy notion of what's going to be happening on Monday at 9 o'clock in class is also generally recognized as a good way of approaching one's teaching. But those are garrulous ways of being. And I wanted to integrate some of the contemplative approach, which I got from the experience from my own life of sitting in silence twice a day in meditation, 20 minutes, just sit down and shut up, morning and evening. That part of my life had been separate from my work as a teacher and a writer and a scientist, and I wanted to try to weave these various strands together into one project, and this is the project here. So there were some personal roots in my desire to sit down and to listen and to let go as much as possible of the agenda. We can't, of course, let go of our intellectual preconceptions, of our emotional attachments, of our sensory filters, but as much as possible I wanted to let those go if I could. The second motivation was a professional one, and that was to use what I had experienced during this watch as a way of structuring the narrative of a book that would hold up and celebrate the ecology, the evolution, the stories of the forest, and the science that lays behind that. And then beyond that, to reflect, not in a prescriptive way, but to think a little bit about what might our relation to the rest of the community of life be. And I think that those questions are, of course, vitally important now that there are 7 or 8 billion of us with increasing appetites. We need to be reflecting on what our relation to the rest of the community of life should be. I think, so there are practical reasons for why we might want to communicate ecological and evolutionary stories to non-specialists, but beyond those practical reasons, for me there's also a deeper aesthetic reason. The Darwinian worldview gives us a window, a lens through which to see the world as this incredibly ancient and layered and storied painting, musical composition. Without the Darwinian view, without the scientific view that has been applied to biology for the last 150, 200 years, we have an impoverished experience of the world. And so to be able to hear from folks who've read the book that I'll never be able to walk through the forest again and not see the mosses or not understand some of the tensions that are happening within those lichens, or not attend to the migration of the birds and what that means in terms of the history of the Americas. Those are things that perhaps have practical value, but beyond that, enrich people's lives. And I think as educators in particular, that's one of our goals, is to prepare people for the workforce and all the rest of it, but also to give them that moment when they're 10, 20 years on from school, they pick up the newspaper and they remember, I understand this now. I understand the importance of this genetic discovery of these ecological processes, and my view of the world is richer. So that's a rather lofty aspiration, but that's what I wanted to offer folks through telling the stories in this book. So, what did I see? What did I try to communicate in this book? The first thing that became very apparent to me, and apparent to anyone who has sat for even a short period watching a particular patch of a natural system, is that the world is ruled by an inconspicuous proletariat. We've heard a lot about the 99% and the 1%, and we are the 1% of biology, the large creatures that are out of the soil, out of the water. Most of the biomass of living organisms are in the microbial world, or very small little insects, the ants and the fungal strands that are weaving their way through the leaf litter and the soil of the forest. And so we hood ornaments on the great vehicle of life need to attend to the engine of life. Who is it who cycles energy and matter through ecosystems? It's mostly the small creatures. Now, that doesn't mean that large creatures like ourselves are uninteresting, or that attention to trees and charismatic megafauna have no place. I think they really do, particularly when we're communicating with non-specialists, but I also think it's important. And much of this book is about celebrating the lives of those small creatures. So let me share just 3 paragraphs here from late in the book, where I'm lying face down on the ground, as I did for quite a lot of the year, prostrating myself with a hand lens pressed to my eye, smelling the leaf litter, and reflecting on what I had observed. So here we're in December, and it's a thaw. I tease away a wet sandwich of 3 maple and hickory leaves. Waves of odor roll out of the opening. First, the sharp, musty smell of decomposition, and then the rounded, pleasant odor of fresh mushrooms. These smells are edged with a richer, earthy background, the mark of healthy soil. These sensations are the closest I can come to seeing the microbial community. The light receptors and lenses in my eyes are too large to resolve the photons bouncing off bacteria, protists, and many fungi, but my nose can detect molecules that waft out of the microscopic world, giving me a peek through my blindness. And a peek is about all that anyone is given. Of the billion microbes that live in the half handful of soil that I've exposed, only 1% can be cultivated and cultured in the lab. The interdependencies among the other 99%. And our ignorance about how to replicate or mimic these bonds is so deep that the microbes die if isolated from the whole. The soil's microbial community is, therefore, a grand mystery, with most of its inhabitants living unnamed and unknown to humanity. As we chisel away at the edges of this mystery, jewels fall out of the eroding block of ignorance. The earthy smell that embraces my nose comes from one of the brightest jewels, the actinomycetes, strange, semi-colonial bacteria from which soil biologists have extracted many of our most successful antibiotics. But antibiotic production is just a small part of the huge and varied role of actinomycetes in the soil's ecology. There is as much diversity within the feeding habits of this group of bacteria as exists within all of the animal kingdom. Some actinomycetes live as parasites in animals. Others cling to plant roots, nibbling on them, while fighting off more damaging bacteria and fungi. Some of these root dwellers may turn against their hosts and kill the plant by below-ground assassination. Actinomycetes also coat the dead bodies of larger creatures, breaking them down into humus, that dark miracle ingredient of productive soils. Actinomycetes are everywhere, yet they seldom enter our consciousness. But we seem to have an intuitive understanding of their importance. Our brains are wired to recognize and appreciate their distinctive earthy smell, and to know this smell as the sign of good health. Soil that has been sterilized or that is too wet or dry for most actinomycetes smells bitter and unfriendly. Perhaps our long evolutionary history as hunter-gatherers and as agrarians has taught our nasal passages to recognize productive land, giving us a subconscious tie to the soil microbes that define the human ecological niche. So in those 3 paragraphs, and this is a process I repeat several times through the book, we start with the sensory experience of the world. What is it like to be out in the woods? And then hopefully draw the reader with their imaginative capacity, draw the reader into the woods. Then describe a little bit of the science of what we understand about this group of creatures for whom most readers is like, oh, what's an actinomycete? Maybe I heard that back in intro bio 20 years ago, but that information has flown my neural system somehow, inexplicably. And then riff on some speculations that some of my colleagues might agree with and some might disagree with. But rooting these stories in sensory experience as a way into talking a little bit more about science and reflecting on our place in this world. Now, these stories about the rule of the inconspicuous are found throughout the book, and I won't do a reading here, just show you some slides. This mountain hollow, as many Appalachian mountain hollows are famous for their springtime burst of wildflowers. Anyone know what this is? Hepatica. So this is one of the more common early flowering plants in the woods of the northeastern United States. It's one of the first harbingers of spring, although there's another flower that is called harbinger of spring that doesn't look quite like this. So these early flowering plants don't offer any nectar. They just offer pollen. And so they're taking a low-cost, high-risk strategy. Here's another one that takes another strategy. The bees love these ones. These are spring beauties that are powerhouses of nectar production. And they have, as you can see, they have pink pollen. So in the springtime, you have all these little native, dark-colored native bees and flies flying around, dusted in pink pollen. It's quite a feast for the senses. But you got to get down on your hands and knees to really appreciate and see that, to get down into the world of these small creatures. So this is a native chickweed. There's also an exotic chickweed that you may be familiar with from gardens. This is Dutchman's breeches, hang out to dry. I'm not quite sure which end of the breeches the Dutchman is meant to put their legs in, but there are a lot of naked Dutchmen running around this time of year. Interestingly here, these don't have an example of it, but often bees will chew in at the end here and rob nectar. So of course the whole point of pollination is there's an exchange of nectar for pollination services, but there are all sorts of ways around that, just as there are in the human economy. Getting something for nothing is something that bees are quite good at figuring out how to do. Now, many of these plants, here's larkspur, one of my favorite, because it's just the purple here is so purple it almost hurts your eyes to look at it, particularly when it's not filtered through a camera and a hard drive and so forth. Many of these plants owe their existence to mycorrhizal relationships with fungi below ground. So appreciate this. If we love the wildflowers, we also need to love the fungal diversity of the soil. Here are some toothwort plants. Trillium, this is red trillium. We have many species of trillium. Bloodroot, one of the early breeders. And here are some bloodroot fruits and seeds. And you can see, here's a seed, and then here is this weird glob on the side. This is an eliazome, and this is bribery for ants. Now, this is actually the biggest bloodroot seed you'll ever see. These things are smaller than the size of a little peppercorn, right? But it's magnificent, just to give you a sense of scale. We're not talking about coconuts here. These are tiny little seeds adapted to bribing ants to disperse the progeny. So the ants will drag this off to their nest. They'll eat this elaiosome, which is very rich in fats and proteins, really good ant food. And then they're left with this, which they regard as junk. And so they put it on their compost heap, which is the perfect place for a bloodroot bloodroot plant to germinate and grow. So again, the lives of the wildflowers, and the wildflowers are the conspicuous things that we visual creatures are very attracted to, depend on the activities of ants and the diversity of ants in these forest systems. Now, what's happening to the ants in the southern US? Fire ants are moving in. What a fire ant will do, which is an exotic species, is eat the elaiosome and dump the seed. And so an example of an exotic species disrupting some of the native interactions that form the foundation of seed dispersal for many of these systems. And it's not just ants. Occasionally deer, and this is a representation of what comes out of the hind end of a deer, easier to catch a photo of than the deer itself. Deer will also nibble at these plants, and for an individual seed, that's not such a good outcome, because this is not a particularly great place to germinate. But for the whole species, this is a really important part of understanding the dispersal of many of these wildflowers into the northeast after the glaciers retreated. So all the wildflowers that are growing in Massachusetts and upstate New York and the Adirondacks and up into Quebec, they weren't there, of course, 10,000 years ago, 12,000 years ago, when there was a mile of ice over them. How did they get there? Well, if it was just up to the ants, they'd have made it to halfway up Birmingham, Alabama. It's because ants don't carry them very far. But a few long-distance dispersal events mediated through large herbivores like deer are very important to understanding the continent-wide distribution of these plants. And we're just coming to realize how important that is. And of course, now what's happening is we've got so many deer that they're grazing the wildflowers down to nothing. So a small number, small abundance of deer, low abundance of deer can be a good thing on a large scale, but too many of them, of course, can have some negative repercussions. Now, this importance of few long-distance dispersal events is echoed in the history of many other species, including our own. Think about the history of human colonization of the world, including of this continent. A few boats with a very small number of people coming from one place or another can completely change the history of the continent. So what we're seeing in the plants here is echoed in some ways. It's not a perfect analogy, of course, but in some ways in our own history. So the rule of the inconspicuous is one of the themes in this book. Another example is the importance of networks in biology. And let me illustrate this with a short example and a brief reading. I was sitting on my rock with my little brown jacket pulled over me, melting into the rock. I'd been sitting immobile for a couple of hours, and a deer walked right up to me. She didn't know I was there. She came within a couple of feet, took alarm, gives her alarm call, and then bounds away with her white tail flashing. Right? So that's particularly in Tennessee, for a deer in hunting season to come across a seated human in the woods is not necessarily a good thing, because a lot of people have a keen appetite for venison. And so she runs away, which that's unremarkable. Many people have heard deer snorting and deer taking alarm. I'd been sitting there silent, listening to the rest of the forest for a couple of hours before that. I could then hear how everything else reacted. Immediately, the chipmunks picked up her alarm call, and the chipmunks are chip, 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 and then chipmunks further out, chip, 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 and a wave of chipmunk alarm calls spread out through the woods, and it took an hour for that wave to finally die down and dissipate. Same thing with the tree squirrels, the gray squirrels. They start up the alarm, spread it out through the woods. Whipper, whipper. The wood thrush, further down the slope, does the same thing. And so animals, particularly the mammals and the birds, are tied together continuously in this acoustic network. And that network is available to us if we just tune our own ears in to hear what these other creatures are saying. So it's a little bit like Facebook, except in the woods, if you miss the status update, you're dead because you didn't know that the sharp-shinned hawk was coming. And from then on, I could tell when people were coming through the woods. There was a trail further down through the mountain slope, and a couple of minutes before people show up, this bow wave of chipmunk alarm calls precedes the arrival of the people. And it's part of our nature as Homo sapiens to travel in groups and often to be chatty and quite talkative and making a fuss. And other creatures notice that and communicate that out into the acoustic communication network that's in the woods. So by tuning our ears to what other creatures are saying, the sounds that they're making, we can learn a lot and become tuned into that network ourselves. Now, of course, that serves as an introduction to the many other ways that networks are important within biology, and I'll share one last reading here with you on that and offer a couple of reflections on it. The animal's acoustic network, the deer and the chipmunks and so forth, has an invisible analog among the forest's plants. When insects chew on leaves, they trigger a physiological reaction from the host plant that not only deters damage to the host, but also alerts neighboring plants. Damaged leaves turn on genes that produce a flush of chemicals. Some of the defensive chemicals evaporate and perfume the air around wounded plants. The wet interior of neighboring plants' leaves are soaked in these molecules, and like aroma in a human nose, the molecules dissolve and move into the surrounding cells. Here, the chemicals turn on some of the same genes that produce defensive chemicals in the original plant. Unwounded plants around the damaged colleague therefore become less palatable to insects. The trees are listening. And when I sit or walk in the forest, I'm not a subject observing objects. I enter the Mandala and am caught up in webs of communication, networks of relationships. Whether or not I'm aware of it, I change these webs by alarming a deer, startling a chipmunk, or stepping on a living leaf. Dissociated observation is not possible in the Mandala. The webs change me also. Every inhalation carries hundreds of airborne molecules into my body. These molecules are the aroma of the woods, the combined fragrance of thousands of creatures. Some aromas are so pleasing to humans that we've domesticated them, extracting perfumes. At least one such perfume, jasminate, is an alarm chemical, communicating danger among plants. Perhaps our olfactory aesthetics reflect a desire to be wedded to nature's struggle. But perfumes are the exception. Most of the forest's molecules bypass my sense of smell and dissolve directly into my blood, entering my body and mind below the level of consciousness. The effects of our chemical interpenetration with plant aromas are largely unstudied. Yet, forest lovers know very well that trees affect our minds. The Japanese have named this knowledge and turned it into a practice, Shinrin-yoku, or bathing in forest air. It seems that participation in the mandalas of community of information may bring us a measure of well-being at the wet chemical core of ourselves. And this, to me, is one of the more exciting things happening in biology, this notion that has dominated biology, the atomistic view that the self is the fundamental unit of biology, is now dissolving. We're now recognizing that the network, the self, I should say, that view is a powerful and fruitful approach to biology, but there's a complementary view, which is the network, the connections, and the flow in the present moment among nodes in the network is a profoundly important aspect of biology. And the notion of the self starts to dissolve. Where do I begin and the forest begins? There isn't a distinct boundary there. And even in that place where we imagine ourselves to be most alone, our nervous system, the thoughts are produced by interactions of networks of neurons, and the nature of those thoughts, the subjective experience of how depressed or happy we feel, is affected in part by the microbial community of our guts. And so our minds, our consciousness is a product of a community, not of a self. And that's an intriguing philosophical issue that I think it behooves us to listen to some of the wisdom that has accumulated over thousands of years from religious traditions, not to understand whether there's a God of this kind or that kind, but to hear from smart people who've been thinking about this question of the tension between the individual and the whole, the network and the self, for many years. And maybe we can borrow some language and see some insights and some fruitful approaches into this new emerging science of networks. Now, of course, in biology, the network is not a love fest of oneness, but a network of cooperation and of conflict, continually being remade and refined. So let me close with a few short reflections on the roots of this book, the study of the particularities of natural selection and natural history. And I define natural history as a study and the appreciation of other species and physical forms of our places, our homes, knowing the names of those community members and some of their stories. The study of natural history has, in many parts of our culture, been in part left behind. And I think this is a problem because knowing one's home, knowing the particularities of how twigs grow and other things that 19th century naturalists got excited about, connects directly to the universal big questions. Say, for example, in climate change, that budget of how much carbon is being drawn down from the atmosphere and being sent back. Well, what does it depend on? It depends in part on the growth of algae and the growth of twigs and the details of the microbial community in the soil. So the big questions are informed, and our understanding will depend on our understanding of the particularities of the details. Beyond that, I think the study of natural history often offers a challenge to academia. The nature of academia, and I'm a great example of that, is that you go to high school in one place, college in another place, grad school another one, postdoc 2, job 1, job 2, and so forth, all in different places. So the questions you ask have to be dislocated. You have to be able to put them in the U-Haul and move across country. So the nature of knowledge, what counts as knowledge, the mobility of academic culture has changed what knowledge is. So we have become dislocated and unrooted. And I think reclaiming some of those roots will produce fruit, good fruit, not sour fruit, within the academies. And so natural history's challenge, of course, is can the particularities of place and of home matter? Might our science standards for schools include at least some attention to the stories of home? And this is not an argument for narrow provincialism. Quite the opposite. The universal is often most vividly revealed through the particular. And the knowledge of microbes and plants and fungi, animals, fans the flames of curiosity and wonder, and deepens the ability to carefully attend to the world. Excellent foundations for the next generation of scientists and citizens and lovers of this world. And so let me conclude by inviting you to consider how you might construct your own experiment, perhaps with your students, children, or grandchildren. Construct a pinhole camera. Find a mandala. Commit to giving repeated attention to a place, not just for an afternoon, but for a practice that lasts for years. And as T.S. Eliot wrote, be still and wait. And I will conclude there, and thank you for your attention.
I think you'll be outside, right? Mm-hmm. So I don't think we have time for questions, but there will be a book signing out in the Great Hall, and Professor Haskell will be there as well, and to sign the book, and you can buy the book. And so thank you all for coming, and enjoy the rest of the day.
Thank you very much.
Thank you.